Dear students, in the previous class we have discussed how to test the significance of one population proportion. Now we consider how to test whether there is any significant difference between two population proportions using independent samples. That is, we test whether there is any significant difference between two population proportions using independent samples. So we have two populations and one attribute. We have two populations, one attribute. And our problem is to compare the proportion of one population with the proportion of the other population having the same attribute, the same characteristic. And we have to see whether the proportion of the characteristics is similar in both the populations. As an example to this, consider a case of a poll of 1,181 US adults to get an idea about the demand for vegetable meals. Of this 1,181, 747 men and 434 women are randomly taken. Simple random sampling is used. Of this, 276 men and 195 women responded that they order a dish without meat or fish sometimes. Or we will say that they will order for vegetarian food. Sometimes they order for vegetarian food. Total women, those men and women who order vegetarian meal occasionally. Now, we have to use this data to see whether the percentage of men who sometimes order vegetarian meals is same as the percentage of women who sometimes order vegetarian meal. Our problem is whether the proportion of men and women ordering vegetarian meal is same or different, or the proportion of or the percentage of men ordering vegetarian meal is less than that of women, greater than, or whatever it is. So the attribute in this example is sometimes order veg. Sometimes order veg. That is the attribute. Sometimes order veg. And population 1, all US men. Population 2, all US women. Population 1, all US men. Population 2, all US women. And P1 is the proportion of US men who sometimes order veg, and P2 is the proportion of US women who sometimes order veg. and our H0 is P1 is equal to P2 and H1 is P1 less than P2. Suppose we want to see whether the proportion of US men sometimes order wedge is less than the proportion of US women who sometimes order wedge. So we have to see whether these proportions are same or different, or same, or the proportion of US men ordering wedge is lower than the proportion of US women. Now let us see how to tackle this issue, how to test the difference between two population proportions. The first step is you calculate the sample proportions. The sample proportions P hat 1 is equal to x1 by n1 is equal to 276 by 741 is equal to 0.369. P hat 2 is equal to x2 by n2 is equal to 195 divided by 430 is equal to 0.449. Then these are the sample proportions, and this is our first step. Calculate the sample proportions. If P hat 1 is much smaller than P hat 2, we reject H0. If P hat 1 is close to P hat 2, we do not reject H0. That is what we do. But we have to statistically establish that P hat 1 is much smaller than P hat 2, or P hat 1 is not statistically different from that of P hat 2. In a given sample, there is a difference. This difference may be due to sampling error. What we have to establish is whether such a difference exists in the population, not in a given sample. So in order to establish this, we must know the sampling distribution of the difference between two sample proportions. We have to know the sampling distribution of the difference between two sample proportions. Suppose that we take one sample proportion 1 and 2, take the difference. You repeat this an infinite number of times, you will get what is known as a distribution between difference between two sample proportions. So, in order to understand this, we first consider the sampling distribution of the difference between two sample proportions, and in the next session we will see how to test a hypothesis about whether the population proportions are same or different. So in this session we will discuss the sampling distribution of the difference between two sample proportions for large and independent samples. Because sampling distribution of the difference between two sample proportions is necessary to establish or to derive the sample statistics. And to discuss the sampling distribution of the difference between two sample proportions, we first summarize our results. Population 1, population 2, and population proportion P1, P2, sample size N1 and N2, number of successes X1 and X2, sample proportions P hat 1 and P hat 2. Number of success simply means number of members sampled having the required or the specified attribute. Here order which, and P hat 1 is equal to x1 by n1, P hat 2 is equal to x2 by n2. We calculate it as like this. Now, given these ideas, given this information, we have to specify the sampling distribution of what is known as the difference between two sample proportions. Now, for independent samples of n1 and n2, for independent samples of n1 and n2 from the population, mu of P hat 1 minus P hat 2 is equal to P1 minus P2. The mean of the difference between this is equal to mean of the difference between proportions in the population. And sigma of P hat 1 minus P hat 2 is equal to, that is the standard deviation, is equal to root of P1 into 1 minus P1 by n1 plus P2 into 1 minus P2 by n2. Sigma, the standard deviation of the sampling, the difference between standard deviation of the sampling distribution of the difference between P hat 1 and P hat 2. And third, P hat 1 minus P hat 2 is normally distributed for a large n1 and n2. So, in order to test a hypothesis about the difference between two population proportions, we use the variable the difference between sample proportions and the distribution of the difference between sample proportions, and it is known as the sampling distribution of the difference between sample proportions, and it is given by these three equations. Mean of the difference between sample proportion is equal to the difference between population proportions. The standard deviation of the difference between two sampling proportion is given by this equation, and the difference between sample proportions is normally distributed for large values of n1 and n2, and this sampling distribution is used for confidence intervals and for testing hypothesis about the difference between two population proportions, and that we will discuss in the next class.